Hello everyone. Today, we are going to learn an exciting topic in algebra, matrices and determinants. These are powerful tools used in solving systems of equations, computer graphics, and more. Introduction to matrices. Let's start with the basics. A matrix is simply a rectangular array of numbers arranged in rows and columns.
Sir, may I ask a question?
Of course. Go ahead.
Why do we need matrices?
Great question. Matrices help us simplify and organize large sets of data, perform calculations quickly, and solve equations efficiently. Types of matrices. Now, let's learn about the types of matrices. Row matrix, only one row. Column matrix, only one column. Zero matrix, all elements are zero. Square matrix, same number of rows and columns. Diagonal matrix, non-zero elements only on the main diagonal. Scalar matrix, diagonal elements are all equal. Identity matrix, diagonal is all 1s rest 0. Symmetric matrix, a symmetric matrix is a matrix such that A is equal to a transpose. In words, matrix A equals the transpose of matrix A. Skew-symmetric matrix. A skew-symmetric matrix is a matrix such that a transpose is equal to negative A. In words, the transpose of matrix A equals minus A. Upper triangular matrix. An upper triangular matrix is a square matrix in which all the elements below the main diagonal are zero. Lower triangular matrix. A lower triangular matrix is a square matrix in which all the elements above the main diagonal are zero. Difference between a diagonal matrix and a scalar matrix. In a diagonal matrix, only the diagonal can have non-zero values and they can be different. But in a scalar matrix, all diagonal values must be the same. Operations on matrices. There are 4 key operations. Addition, subtraction only if matrices are of the same order. Scalar multiplication, multiply each element by a constant. Matrix multiplication, number of columns in the first must match rows in the second. Transpose, interchange rows and columns. Determinants. Next, we study determinants, a single number representing certain properties of square matrices. For a 2 by 2 matrix A equal A, B, C, D, then value of A equal A, D, B, C. Determinants help us find the area, solve equations, and determine if a matrix has an inverse. Suppose we have the matrix 3, 4, next row 2, 5. The formula for the determinant of a 2 times 2 matrix is AD minus BC, that is, the product of the first diagonal minus the product of the second diagonal. Here, the first diagonal is 3 into 5, which gives 15. The second diagonal is 4 into 2, which gives 8. So, determinant equals 15 minus 8, which is 7. The matrix is first row 2, 4, 1 second row, 3, 4, 1 third row, 5, 1, 3. To find the determinant, we expand along the first row. That means we take 2 into the determinant of the submatrix formed by removing the first row and first column, which is 4, 1, 1, 3. That determinant is 4 into 3 equals 12, minus 1 into 1 equals 1. So it becomes 12 minus 1. Next, we subtract 4 times the determinant of the submatrix from removing the first row and second column, which is 3, 1, 5, 3. That determinant is 3 into 3 equals 9, minus 5 into 1 equals 5. So it becomes 9 minus 5. Finally, we add 1 times the determinant of the submatrix from removing the first row and third column, which is 3, 4, 5, 1. That determinant is 3 into 1 equals 3, minus 5 into 4 equals 20. So it becomes 3 minus 20. Putting it all together, 2 into brackets 12 minus 1 close brackets, minus 4 into 9 minus 5, plus 1 into 3 minus 20. That is 2 into 11 minus 4 into 4 plus 1 into minus 17, which is 22 minus 16 minus 17. That equals 11. Properties of determinants. Let's look at some key properties. Swapping rows or columns changes the sign. If any two rows or columns are identical, the determinant becomes 0. Determinant of A equals determinant of A into determinant of B transpose doesn't change the determinant. These properties are useful for quick simplification. Today, we are learning about the adjoint and inverse of a matrix. The inverse of a matrix A is given by the formula A inverse equals 1 divided by determinant of A multiplied by adjoint of A. The adjoint is found by taking the transpose of the cofactor matrix. To get it, first find the cofactor of each element, then arrange them in a matrix, and finally take its transpose.
Sir, what if the determinant is 0?
Good question. If determinant A equals 0, then the matrix has no inverse. It's called a singular matrix. Solving system of equations. There are two matrix-based methods. Matrix method x equal A superscript 1b. Cramer's rule. Use determinants to find variable values. Let's take an example. 2x plus 3y equal 8. 3x plus y equal 5. We can use Cramer's rule to solve it step by step. Extra concepts to more important ideas. Trace of a matrix. Sum of diagonal elements. Rank of a matrix. Number of linearly independent rows columns. These help in advanced applications like computer science and statistics. Summary and conclusion. Let's summarize what we learned today. Types of matrices, matrix operations, determinants and their properties, adjoint, inverse, and system solving. Bonus, trace and rank. That's all for today's session. See you in the next class, and until then, keep practicing. Jai Hind.